All right, good morning, everyone. We're going to get started with our MinStack forum. Today, it's my pleasure to introduce Dr. Grant Thompson. Grant is an assistant professor at Iowa State University in the Department of Horticulture. He's also a professional landscape architect and teaches classes in plant ID and design at Iowa State University. And today he's going to talk to us about some tree diversity issues and a paper that has just been published. So I'm sure he'll update us on that and where you can check out the full research. And Grant, please,
all right,
if you're ready to get started.
Sounds good. Thank you all for the introduction and for having me here today. As is mentioned, a large part of what I do is teach. So I'm used to watching the chat and answering questions as we go. So by all means, I don't mind interruptions if it helps. So as was mentioned, I'm talking today about some recent research that we've done looking at different consultant disciplines and tree diversity. A few co-authors on this study are Marcus Jansen. He is a recent master's student of mine, just leaving town today to go start a job at Ball Horticulture. And Audrey McCombs, she's a current PhD student in biology and evolutionary sciences. So some learning outcomes for today. I want to maybe have you all start to consider how different professional consultants might actually affect the composition of the urban forest and how that might be different on public lands or private lands. So I'll dig into that in a little bit. I also want to introduce the idea about how site plans that are used in the design and engineering sector might be of value to urban foresters as a source of data to look at how those professional consultants might be shaping the urban forest, different kinds of urban design and policy implications of that as well. And finally, I want to help not only just develop the awareness of tree diversity, but also kind of the taxonomic way, so genus, species, family, that we might be used to looking at this, but also at the genetic level, so digging into cultivars and why this might be deserving of more attention in the urban forestry community. So before I get started, I want to touch on some acknowledgments because, of course, I don't work in a vacuum. There are a great many people who are very important to this work. So Connor Evers and Justin Wigdahl were both undergraduate researchers in my program, have gone on to good things on their own. And then Marcus Jansen, co-author on this paper, recent graduate. So I am a landscape architect. I practiced for about 5 years before returning to graduate school and research. I'm the director of the Sustainable Landscapes and Management Lab here at Iowa State. I do woody plant ID, plant installation and management, plant propagation, and landscape construction. So a lot of my research comes from a very practical perspective, things that I encountered as a practitioner and things that come up in the classroom. I've presented some, or I guess I'm a member of the Campus Tree Council here at Iowa State. We're a Tree Campus USA, so that's part of one of the things that I'm involved with, as well as the Iowa Urban Tree Council by our Department of Natural Resources. I've presented work at Shade Tree Short Course, the Iowa chapter of the American Society of Landscape Architects, and ISA. So relatively new to the position, but trying to get myself out there. So as I mentioned, I am a professional landscape architect. I worked for a number of years on different kinds of ecological projects in sensitive areas, but also, pretty typical urban construction projects. This is the Central Iowa Shelter and Services building in just south of downtown Des Moines. This is an emergency housing facility for folks who are experiencing homelessness and also veterans who are transitioning maybe out of the service or need some additional support. And so this is pretty typical of most kind of construction projects, whether we're talking about landscape architects, civil engineers, architects. There's some sort of development drawings that go along with this. In case of a landscape plan, we're usually talking about a planting plan showing where things are located and a plant schedule detailing all of the information about these plants. So this would be botanical names, common names, cultivars, if they're included, the size of the plant material, and so on. And these documents are made for two primary reasons. The first being it communicates the design intent to the contractor who's actually going to build this, because as landscape architects, many of us are probably more desk jockeys. We design it, but then other people build it. But also these documents are useful for communicating these to city officials, whether that's an urban forester who might look at this or anyone else in the permitting department who actually gives the go-ahead for allowing us to do these constructions. So, we take these conceptual designs, really document them out, and then ultimately that allows us to build these things, or the contractors. And so not only do these, look very nice and pretty as they get built, but they become that part of the urban fabric that is needs to be managed, both by the private client or the owner of the site, but then becomes part of that fabric of the city. And so those trees that get specified by a landscape architect, me and my colleagues in this case, become those trees that now a city forester would need to manage. Additionally, there are private trees on site. This one happens to be a little bit unique because it abuts some city property. So in addition to the typical right-of-way trees, which would be public trees and part of that public inventory, there are some trees on technically private land, but the city has offered to manage those trees and so includes that in their own inventory. So these landscape plans do help us delineate between public and private trees, and may be a useful source of information for assessing tree diversity even beyond what is typical of, say, community tree inventory. So transitioning a little bit, of course, as we talk about community tree inventories, one of the large reasons we do this is to manage those inventories and to hopefully protect ourselves against emerging threats, whether they are biotic pests like emerald ash borer or abiotic threats such as climate change, freak weather events, drought, you name it. So emerald ash borer, I'm sure this is old news to many of you, but was introduced in Michigan, is spreading throughout the Midwest, and the impacts of emerald ash borer are just staggering. I mean, the economic value of ash trees in the U.S. was estimated at north or close to $300 billion for more than 125 million trees. And that's the standing value. Now, of course, when we lose those trees, we have to spend money to remove them. So there's another about $10 billion over a 10-year period for the treatment, removal, or replacement costs. And then, of course, when we lose those trees, we lose not just the standing value, but their functional benefits in the landscape. And so that's whether that's canopy tree filtering, urban heat island mitigation, and so on. These can have real human health impacts. One study looking at about 15 states over a 5-year period attributed over 6,000 lower respiratory deaths and 15,000 cardiovascular deaths to tree loss related to emerald ash borer. So certainly it's not just the trees, there's major impacts on human health, municipal budgets, and so on. And emerald ash borer is just one of a number of different problems. We had Dutch elm disease before that. And so this is one of those reasons why it really matters what our urban forest, both the public and the private, is comprised of. Here, for example, and there are many of these that could be drawn upon, but this one was an ash tree at a very prominent location here on the Iowa State campus, or just off campus rather. This tree was at the corner of Lincoln Way and Ash Avenue. Ash is where we have a lot of fraternities and sororities located. There's 2 large dormitories there. So this particular intersection receives probably some of the most pedestrian traffic of anywhere in Ames. And of course, ash trees on Ash Avenue will all be gone. So, this is not uncommon of many places that are being affected by emerald ash borer, but, the very nature of our urban fabric is changing and will be unrecognizable. So when we talk about diversity, of course, diversity is a kind of insurance. And it's interesting that we can actually look to economists and economic theory to help us better understand ecology. So, when we think about stock portfolios, we might think about diversification as a way to mitigate risk. So what's riskier? If you have all your money in one stock, say Boeing, for example, this is from about 2019, had a nice stock price sitting here at about 440 a share, and something happened. If you're not familiar, this would have been the first incident of the Boeing 737 MAX airplane crashing. You can see their stock price drops a little bit after that. And shortly after, there's another incident which resulted in this extreme decline. And that would, of course, be the second crash of the 737 MAX. So when we find ourselves in an, eggs all in one basket or a few basket scenarios, we can experience extreme or severe losses. Now, of course, if you follow economic theory or have a financial person, they would recommend a diversified stock portfolio to help mitigate some of these risks. You might lose out on one stock, but hopefully those freak accidents, as opposed to a whole market effect, only affect that one, and your finances are better off elsewhere. So that diversified stock portfolio is a way to help mitigate risk when unknown outcomes might occur. And in the economic theory, we actually call this the insurance hypothesis. So diversity as a form of insurance. Now, of course, we can think about this in terms of the very specific biotic threats like emerald ash borer, Dutch elm disease, and so on. But we can also think about this in terms of abiotic effects. So we, in August 10, 2019, huge derecho moved through the Midwest. Basically, you can think of this as a land hurricane without the rain. Of course, it did rain, but we had sustained winds in excess of 100 miles an hour. Cedar Rapids here in the kind of north central part of the state, extreme canopy loss. Greater than 50% of all the trees in the city are just gone. But while that's an extreme event, very rare and is not specifically affecting certain trees on the case of biotic resistance or disease resistance, you probably still could tick through a mental list of weak wooded trees that would fare worse in this kind of wind event, and more strongly wooded trees or ones with better branch angles, better connections, that might fare better. So even when we have these kind of indiscriminate abiotic threats, we still see species differences. So again, having a diversity of trees in our inventory can help mitigate some of these risks. So when we think about some of these public inventories, of course, there's been research kind of up the wazoo about this, but it's always staggering what we find. So when we do an inventory, we are of course trying to understand what are the number of trees that we have, the number of species, the relative proportion, and so on. What is the composition of community trees in our community? So this study by Ma et al. Looked at urban forestry research, and they asked municipal foresters, what are the 6 most common species in your community? And they looked at surveys all the way back from the 1970s and up to 2014. They looked at over 600 communities across the US. And while the species list differed depending on where we are in the country, as one might expect, they still found the striking result that the top 6 species in any community accounted for about 61% of all of the trees. And that number 1 most common tree accounted for about 23% of all of the trees in that public inventory. So that really does mean that if something comes along, emerald ash borer, a strong wind, and these are weak wooded trees, whatever the case is, if something comes along and affects that single species, we're losing 24% of our trees in our community. So certainly this is a big risk. And urban diversity guidelines have been discussed in the literature and elsewhere for more than 30 years. One of the very common ones that's still used, debated, but still used, was introduced by Frank Sotomayor in the 1990 Metric Conference, called the 10-20-30 rule. and or formula. And it stipulates that we should have no more than 10% of the trees in our community of any one species. So Acer rubrum, for example, red maple, or 20% in any genus. So that would be anything within the maple or the Acer family, or no more than 30% of any family. So this would be the Sapindaceae family, of which maple is a member, and any other members of that family. Now, again, I say this has been debated. For example, John Ball in the American Nurseryman in 2015, so 6 years ago now, said, 10, 20, 30 is great, but really we need to have more diversity at even the genus level. So we need to step back to give ourselves more protection against, say, something like emerald ash borer that's a multi-species threat. It's affecting the entire genus of ash. So Ball suggested that we have no more than 5% of any one genus. So for comparison's sake, we're going from 20% of any genus in the Santa Mayor 10, 20, 30 to the 5% genus in John Ball's suggestion, Dr. Ball. And so this means that we need to go from 5 genera in our entire urban tree lists to more than 20. So again, a big shift in thinking when we either prescribe different numbers or we think about different levels of taxonomy where we might look at this. But I want to take a step back before we talk about 10, 20, 30 or any of these other diversity rules. And I want to think about how diversity has been looked at in terms of plant ecology. So where do these numbers come from? What does it even mean? And in plant ecology, which is really an outgrowth of forestry management and natural resources, thinking about timber and lumber management, how do we describe a stand of forest trees? And how do we describe and compare different stands across a landscape? If we do something management-wise here, how does that differ than something else? Or if we are looking at virgin forests or second growth forests, how do we look at where certain species might be? And importantly, and I'll bring this up a couple of times later, cultivars are not even considered in this case. There's no natural analogy in a forest system to a cultivar or a cultivated variety that we would use in a horticultural or urban forestry system. So when we look at plant diversity, usually at a site scale, and I'll come back to that site definition here in a minute, we're looking at 2 variables. We're looking at richness, which is strictly a measure of the number of species. And this was always typically done at the species level, although we could look at different taxonomic levels. And we're looking at evenness, which is the proportion of a species within an individual site. And I use site here loosely because it's described by the person measuring it. Maybe it is a very small plot that they're measuring. Maybe it is an entire wooded area, which could be many acres or hundreds or thousands of acres. Or maybe it's an entire state or region. So site here is loosely defined because it's defined by the person measuring. So in this example, where we're considering richness, which is again the number of species, I have this example here where we have 3 different sites and we have 4 different species where we're looking at this. And so when you look at this, sites 1 and sites 2 each contain 4 different species, and site 3 only contains 2 species. These species C and D are not present at site 3. So if we were strictly looking at richness, we would say that sites 1 and 2 are equal, both have 4 species, and that site 3 is less diverse because it only has 2 species. But you can see that the distribution of those species, so that numeric counts of the individuals within those species, are a bit different. When we look at evenness or the relative proportion, we're trying to consider the distribution. So for example, we can look at site 1, which is even across the board. It's 25% of each of our 4 species. Or we can look at site 3 and say that it is 50% of the 2 species that are present. Whereas site 2 is mostly dominated by the species A, and there's this smattering of others. So if we looked at this from an evenness perspective, we would say that sites 1 and 3 are equal, and that site 2 is the less even distribution. It's mostly just this one species. So really what this comes down to is we need to consider both richness and evenness when we are describing and measuring diversity. And Claude Shannon developed the Shannon Index for this. It's a mathematical relationship that combines richness and evenness such that the higher number is considered more diverse. You can see that in the numeric weighting of this high prevalence of a single species in site 2 really drops the value here. And the more species that are more evenly distributed increases that value. So really this is picking up on that site 2 being closer to a monoculture, which is why it's penalized here in the Shannon score. And as I mentioned, when we look at richness, we're really looking at species in the landscape. So here are 3 different plant lists. This happens to be from the data set that we were analyzing. And you can see these different ABs species. In one site, we might have Balsamea, concolor catechins, and Fraser. This gives us 3 species. And again, here, if we have Balsamea, concolor, and Fraser without the catechins cultivar, we still have 3 species. But in this composition, where we have both concolor and concolor catechins, that is only 2 species between those with Balsamea in the mix. So what I'm saying is if we don't consider cultivars, our richness levels change a bit. But if we do consider cultivars, we may look at this a little bit differently. And cultivars are, of course, important because they're popular, they're profitable, they're predictable. They often have some superior characteristics, whether it's form, color, disease resistance, something that we desire in the landscape, which is why we specify them. But they are not the same as the true species. And again, cultivars are generally not considered in forestry research or urban forestry research because there's just really not an analog. But I hope to convince you by the end of this presentation that maybe we need to consider cultivars a bit more. A different idea of thinking about diversity is how we look at this at landscape scales. So I said when we look at richness and evenness, we're looking at a site or a multiple sites of whatever scale we happen to think about. But if we want to compare diversity between sites or across multiple sites in a landscape, that's really what Dr. Whitaker got to thinking about. And he describes these as alpha, beta, and gamma diversity. So alpha diversity is the number of species or the richness within a single site. So if I go out and I check my 10 meter by 10 meter plot, the number of species that I find in there. Beta diversity is the difference or the difference in overlap between species across 2 sites or multiple sites. So which species are present here and which species are present there that are different. And then finally, gamma diversity is this landscape diversity. So if we consider all of the sites that we're looking at in our study region, what is the total species palette or richness that we find? And then how do our individual sites within that relate? So you can see in this Venn diagram here, we have site 1, we have a certain number of species that are here. This is the alpha diversity of site 1. Site 2, we have the alpha diversity of site 2. There's some overlap between them. So the difference between those is the beta of site 1 and the beta of site 2. And then that total species list is our gamma. When we have a site with a lot of species in it, such that it's completely inclusive of all of the species in the region, beta drops out. So just something to think about here. Bringing this back to site plans, which is kind of where I was going with this, site plans are the embodiment of lots of levels of regulation. So we can look at state laws and guidelines in terms of which consultants are allowed to do work. We can look at municipal laws and guidelines, so how many trees we need per foot of right-of-way, and so on. We can look at local planning levels. This could be maybe the tree list that a particular city forester might like. And the state laws, as I mentioned, can dictate which consultants can do the work. So what is their disciplinary training? What do their professional organizations or industry organizations, what are they advocating to their people? And then finally, to the individual designer or firm plant preferences. And all of this gets tied up in a site plan. So we can look at a site plan and we can start to tease apart some of those things. And even if we can't separate them, if we look at enough site plans, maybe we can see patterns emerge. And of course, this does affect the diversity of plants at a single site. So in a site plan, if we have lots of site plans in an area, a downtown core or something, we can start to see neighborhood plant diversity patterns across an entire community. And even if we look at multiple communities at a regional scale. And of course, this ultimately gives the ecosystem services that our urban forest is providing. So through this intermixing of these policies and consultants, we may actually have outcomes affecting those ecosystem services that, of course, we're trying to provide and manage. So when we look at a site plan, and this is one from my time in practice, this is that Central Iowa shelter that I mentioned earlier. This is not one of the ones included in the study because any of the plans that I looked at, while they're publicly available, I didn't want to share that information publicly. So I'm not calling out any particular designers, consultants, et cetera. But we have our public right-of-way indicated, we have our planting notes, we have our plant schedule with all of the plant details. And importantly, we have a title block. And from that title block, we can get information about which the consultants were, who signed off or stamped on the drawings. Usually with a cover sheet with these sorts of permitting sets, we would have information about open space and so on. So lots of just rich detail in these. So in Iowa, architects, civil engineers, and landscape architects can all specify plants for a site. And we also have certified nursery professionals. And this is an industry certification through our Iowa Nursery and Landscape Association. So my question was, I don't know how much architects really study plants. My guess isn't much. Maybe we have an occasional architect who does. Probably something similar with civil engineers, landscape architects, presumably it's part of their training, and nursery professionals, again, whether that's in school or in practice, probably receive some of that training. So there's probably this knowledge gradient amongst these professionals in terms of not only plant materials, but some of these importance of diversity. So maybe there is a difference in terms of who's specifying what and how could we tell? Well, we can look at site plans, which is what we did. This paper came out last week in Urban Forestry and Urban Greening. This is an open access journal, which means anyone can download it and look at the whole thing. There's no paywall here. We also will soon be having the entire data set posted publicly, so folks can take a look at this if you want. There's also a pretty big supplement to this, which includes the entire plant lists of everything that we looked at. So if you want to get into the weeds about what was being specified in Iowa City and Des Moines, we can get into that. So we thought that consultants might affect the diversity of trees on a single site. We thought that there might be an effect of open space where you have more open space, you can have more trees and greater diversity. And finally, we thought that if you had a consultant with more training when it came to plant material, that there might be differences in terms of what they use across sites. So they have a larger plant palette, they can pick some here and they'll pick something else over there. And that would increase the diversity of materials used across the landscape. So we were looking at this amongst architects, certified nursery professionals, civil engineers, and landscape architects. And so to do this, we use those information off those site plans. We picked Des Moines and Iowa City because they are populous in the state of Iowa. They have a very similar climate in terms of temperature and rainfall on a yearly basis. They're about 100 miles apart, so sourcing of plant material between the two cities should be similar-ish, and they're at the same latitude. So all of this means there will be fewer differences in terms of the plant material that one might reasonably expect to show up in these cities. So we looked at 4 years of plans, 2015 to 2018. We looked at almost 160 plans. This resulted in over 4,800 specified trees. And just in terms of a data set, this is a highly usable data set. So of all of the site plans we reviewed, almost 95% had something we could use on there. Where they didn't, they either just didn't have plant material at all, or we couldn't figure out which consultant was actually responsible for that landscape plan. So if you're used to surveys with really low response rates, these site plans may be more valuable. So really high level review. Landscape architects in our study did most of the sites and specified most of the trees. So maybe not a surprise that in general, or maybe not a surprise that the landscape architects will be a big part of this story. We found some major differences between the cities. So in Des Moines, landscape architects did a lot of work, but in Iowa City, almost 91% of the projects, the site plan was developed by a civil engineer. Interesting. Architects didn't do many projects, but most of the ones they did were in Des Moines when they specified planting plans. And these certified nursery professionals were only doing work in Des Moines, not Iowa City, at least in the plans that we looked at. So what ultimately this means is we don't have a whole lot of projects for architects and civil engineer, certified nursery professionals that we can say a lot about, whereas we can say more about landscape architects and civil engineers. In terms of the trees, again, landscape architects specified about 60% of all the trees, civils next, and on down the list. So getting into the heart of what we found that alpha diversity, as one might expect, increases with site size. So as you have a larger site, and in this case, I'm particularly talking about open space, so spaces where we can plant trees. As the site size increases, the diversity increases. Okay, we kind of expect that. But what was interesting was when you get to a really large site, a site with at least 6 acres of open space, the civil engineers specified about 3 less selections, and this includes cultivars, species and cultivars, than landscape architects. So at these large sites, a civil engineer is specifying a less diverse plant palette than a landscape architect might. Overall, beta diversity was very high across all the sites, and that simply means we didn't see a whole lot of repeated plant lists site to site. So there was not this kind of rubber stamping of a planting plan. Things were really different site to site, which is probably a good thing, but again, it depends on the context of the research. When we look at these plant palettes, landscape architects used most of the species that other consultants did. So when we look at this heat map, if you read it across the row, so this is the proportion of the trees used by a particular consultant discipline. So for example, this is the line of trees used by the landscape architects. This is saying that about 77% of the trees that an architect specified, the LAs also specified. So here again, with the certified nursery professionals, about 85% of all of the trees that a nursery professional used, the LAs did too. So again, we can see over here, when we look at the LAs, we can see that there are a lot of trees that other folks are not using as well. So again, the LAs are using most of the same things that everyone else are, and then quite a bit more. And again, we can look at this at an intraspecies, so when we consider cultivars also, or we can look at this at a species level. And either way, landscape architects are providing most of the plant material, or where we see a lot of differences. So for example, 41% of the diversity, or almost 90 selections, are only used by landscape architects, and not by anybody else. And again, we can see this at the species level. About 27% of the total species list between these two cities, or about 30 species total, were selected by a landscape architect and not anybody else. Now, I'll make a point here that when we talk about diversity and these selections, we didn't ground truth these site plans. We did not go to the sites to verify, one, what was specified was actually installed, and two, if it was a good selection or an appropriate selection for the site. We were interested in what was specified, and we were interested in the kind of professional judgments of both who was specifying the project and probably the city officials that signed off on it. So hopefully glaring mistakes were caught, but in either way, we can't verify that in this data set. Another striking thing that came out was the cultivar usage. So not only did landscape architects work on a lot of projects in our data and specify a lot of trees, but they used cultivars about 60% of the time. And that was much more than the other consultants, 35 to 45%, depending on which consultant group we're talking about. But in the entire data set, about 54% of all of the trees, the 4,800, more than 4,800 trees specified, were cultivars. If we jump back and we look at that 10-20-30 formula from Santamayor, and we look at this across the entire data set, so all of the counts of all of the species, only one species, Glididicea triacanthus, or a thornless honey locust, came in at over 10%. This is just a snippet of one of the tables where we're looking at species. So we have swamp white oak, Quercus bicolor, and Quercus rubra red oak. They came in at number 2 and number 3, most specified, well under that 10-20-30. So across the entire plant list, we don't see a whole lot of problems here. And it's interesting for us that Acer, came in at number 13 at only 2.5%. And again, when we looked at this, it's within the data set of these specified planting plans. We did not look at the entire city's inventory to determine if what was specified here is filling gaps or exacerbating problems in these city inventories. So this is strictly looking at the site plans. When we dig into that Glidicea number, so we said about 10% of everything specified was one of these honey locusts. It's interesting because some of them were maybe misspecified. I don't think anyone would really want a non-thornless honey locust in their landscapes. But if you look at who was maybe misspecifying those, it looked like a lot of those came from our civil engineers and maybe even some of our nursery professionals in LA. So again, not quite sure what's going on there. But if we look at the rest of these in general, about almost 90% of the honey locusts were one of 8 cultivars. So again, this cultivar thing is creeping in. I'll talk about that in a minute. If we look at consultants, so are any consultants particularly bad at violating 10-20-30? Generally, no. And when they do, it's not by much. So we see a little bit of creep in our honey locusts. It looks like the certified nursery professionals are using sycamore maybe a bit more than they should, and things in the pine family maybe a little over by architects, but nothing grossly exceeding 10-20-30. If we look at it at an individual site, so instead of looking at all of the consultants' work in total, if we look at the site level, no single site met 10-20-30. Now, 10-20-30 was developed for managing a community forest, but some folks have looked at the individual site level, which is what we did here. So it's kind of an overreach, if you will, over applying 10-20-30, but it's interesting. And in fact, 42 projects, or just over a quarter of all of the sites that we looked at, had fewer than 10 trees on them. Small urban sites, not a lot of open space, so less than 10 trees. So there's no way they can meet that 10% species threshold. We see a little more compliance at the genus level and more compliance at the family level. But our, say, for example, our architects, which again, not a lot of projects, so you take it kind of with a grain of salt. They're really never or rarely meeting it at the genus or the family level, whereas even with civil engineers, we don't see adherence at the genus level. So what about this cultivar thing? I've brought this up a few different times. When we have a cultivar of a plant, the scion, or the top part of the plant, is a clone of the original selection. That's that cultivar that we want to see. And that can be done through cuttings, through tissue culture, through grafting or budding. In the case of grafting and budding, and even tissue culture, which may give us scion material, those may be on a rootstock, and that rootstock could be seedling derived. So there may be genetic diversity in the rootstock, but there's not really genetic diversity in the scion or the upper part of that plant that we're interested in as our cultivar. Now, there are rootstock scion interactions, so we can see kind of a modulation of the performance of the scion based on the unknown genetics of the seedling rootstock, but not much compared to the limitations or kind of the genetic capacity of that scion material. And so when we think about cultivars, clearly form, if it's an upright or a narrow form for an urban space, if it has spectacular fall color, whatever the case is, form is often what we're thinking about. But it's not the only thing we think about. We do think about function when it comes to cultivars. For example, disease resistance. So Dutch elm disease resistant elms, that is a function that we have clearly selected for. But it's also interesting that we have differences among cultivars arising elsewhere for functional traits that maybe we haven't selected for. So this is a paper by Sojum. They were looking at drought stress in Acer or maple species. So they have a whole number of different species, but they also included some cultivars of those species. And so the plants here at the top of the list are less drought resistant. The ones at the bottom of the list are more drought resistant. In this case, the greater the negative number or the more negative it is, the more drought resistant it is. And what I've highlighted here are the cultivars where they did find that among Acer saccharinum, there are cultivar differences, statistically important cultivar differences. Is this practically important? It's getting into the range of it might be. And again, we see differences among red maple cultivars. So we do see cultivar differences which may play out in the landscape. And this has been brought up before. This is part of an abstract from some Virginia Lohr's research, 2013. Basically, she was saying that urban forests may have issues because of this uniform genetics, and that we may be losing the resiliency of some of our trees if we have this narrow genetic base resulting from cultivars. They did a survey of wholesale nurseries in Washington state. And while a lot of the folks responded that they were aware of diversity and genetic diversity, they really didn't understand what to do about them. They dug into this a little more, did some surveys, and found that the significant areas where you can maybe impact people's understanding of diversity, either taxonomically or genetically, really came in from school or college or trade journals and articles. So what does this mean for this consultant thing that we're looking at? Well, landscape architects and the certified nursery professionals probably have some professional training where in school they might come across these topics. And certainly any of these consultants could be reached by trade journals. Educational research would, say the more exposure one has to this, the more important that is, or the more strong of an understanding they would have. So our LAs and our certified nursery folks, would have that double exposure between school and trade journals. But it's also important to hear the strength of that trade journal. It looks like these could be good places to put these messages to help get these points across. So, kind of wrapping this up, when we looked at civil engineers, at least in the sites that we looked at, they were associated with lower diversity than landscape architects on really large sites. But those really large sites are important areas for us to be able to have more diverse selections. So maybe that's a missed opportunity. Maybe that raises some questions about who, as a professional consultant, should be involved in those large projects. I'll leave that there because that is a big can of worms. I'll also think about that difference between cultivars and horticulture versus kind of the forestry only exclusive of cultivars mindset. And one, some of these diversity metrics don't really capture cultivars or diversity in a horticultural landscape. And it's possible that widespread usage of just a few cultivars may undermine some of this taxonomic diversity. That said, if we are diversifying in species, genera, and families, the effect of cultivars will probably be small but not negligible. So also this kind of does bring up the idea that 10, 20, 30, or whatever diversity benchmark we want to look at could be used by consultants as kind of a quality control check. So on a site that they might be developing, could they look at their plant palette, trees, shrubs, perennials, you can look at the whole thing, and can they start to think about diversity and what that means at a single site, not just how that site plugs into the entire landscape. A couple of limitations I will completely acknowledge with this study. Done in Iowa, 4 years of plans, 2 cities. That is a good amount of data, but it's not really something we can extrapolate. From a statistical sense, this was a census of the data. We looked at all of it, so we can't make projections about it. But we could use this approach elsewhere. We can look at site plans in other communities to validate what we found or contradict it. That is sometimes the case. And where we see divergences, that may be related to what is allowable in those communities. Do state licensure boards or legislatures or even community level policies alter who does the work or when different folks are involved? I want to just come back to this site plan as an alternate data source and one that might be really valuable for consultants. These are public records, so city officials can certainly take a look at these even if they weren't public records. They're submitted for permitting, but this can also give us a insight into both public space and private space. And lots of different questions could come out of looking at site plans. We might be able to think not just about trees, but shrubs and perennials, native versus not native plants, plants that are more supportive of pollinators, this cultivar issue. We could look at the diversity of material, appropriateness, and so on. You might be able to also look at some policy things. So if we have allowable and not allowable planting lists, how do those come into play on these site plans and any maybe unintended policy implications? So as I started off, I wanted to get you to think about how different professional consultants might affect the composition of the urban forest, both public and private. We found that landscape architects increase diversity overall, maybe at the cost of too many cultivars, and that depending on the site size, civil engineers might be specifying things that are less diverse than landscape architects. I asked you to try to understand how site plans and permitting documents might be a useful source of data. I think we've done that. And to develop an awareness of tree diversity, both taxonomically and genetically. In our data set with as many cultivars as we found, this is interesting and something that deserves further consideration. So based on all of this, I think landscape architects are probably the primary outreach, at least in our communities, since they're doing a lot of the work anyway. So if they're already planting a lot or specifying a lot of trees, let's reach out to them first. I do think this maybe might cause us to think about some of these policy level things and how we might be able to positively influence things like diversity or manipulate it in a way that is desirable. And these cultivars, again, relative to species or family or genera, aren't going to sway anything too greatly, but it is something to be aware of and something that is often missed in community tree inventories. So I'll leave this here, open it up for questions, discussion. Again, just want to acknowledge my co-authors on this, Marcus Jansen and Audrey McCombs, as well as the undergraduate researchers, Connor and Justin, who are a big part of this. Thank you.
All right, thank you very much, Grant. A lot of great information. If there are any questions and somebody would like to either unmic themselves and just ask it, or if they want to pop a question in the chat, sounds like Grant is more than happy to answer anything that you've got questions about. While we're waiting for that, if people are thinking about their questions, Grant, I think it was interesting what you had mentioned about the civil engineers. I forget which city it was, that they actually had a pretty good influence on the plant diversity list. Do you know, and maybe your data didn't show this, but do you know, was it the actual civil engineers coming up with those, or they may be getting those lists from somewhere else and just plugging them in?
So that is a great question, and both kind of a pro and maybe a limitation of this approach. When we looked at our data set, it wasn't the overarching or the prime firm that we looked at who specifically was signing for the landscape sheet or the planting plan. So if you have a multidisciplinary office that is maybe more civil, but a landscape architect did the planting plan or a certified nursery professional subcontracted and did that, that's what we captured here. Now, I know in some firms, someone might be doing the drawings and someone else might be signing off on them. We can't account for that in our data. It's a great question, though.
Yeah, I think it's interesting. You pointed out that landscape architects might be who we do our first outreach to in terms of talking about whatever diversity goals might be for a community that you're working with. But it seems like, at least in some communities, if civil engineers are doing a bulk of those plans, that would maybe be your next group to really work with. And do you think there's value in trying to pair civil engineers with the nursery professionals? It sounds like maybe nursery professionals were being underutilized in some of the cities you looked at.
Yeah, the prevalence of those nursery professionals here in the state of Iowa, there are some, but they're certainly not as common as civils or landscape architects. So, in terms of those professional collaborations, they're so organic depending on the needs of any different project or client. But yeah, I mean, outreach and connection and education anywhere we can, partnerships wherever we can create it. And, I think part of it, if you are in a policymaking role or a city forester role, part of what you may want to do in any of those pre-construction meetings, scoping meetings, whatever, try to have those conversations about diversity and maybe even explicitly, here's our allowable plant list, but in this part of our community, we are way over on maples. So I know maples on our okay list, but could you just not pick maples this time? Whatever the case is.
Do you have a suggestion about for communities that are putting out lists of plants that are acceptable as a sort of a recommendation, or your thoughts on, is it better to put out, here are the species we would like to see, or here are the species we absolutely don't want to see, kind of the here's the for or against sort of lists?
Sure. It's a good question. And I would say certainly the against list has value. If you have things that you're learning to be invasive and just don't want to see anymore, make that super clear. Calorie pair, I'm thinking of you. But, in terms of the allowable list, instead of particular species, maybe we ought to think more functionally. If we are thinking about, whether it is the size of the canopy or the stature of the tree. And I know we do that already with like understory trees for areas with power lines, but it's not so much what species do we want to see, it's what do we want to get out of those species. And if we can define the problem that way, then we may have more leeway in terms of the species that might fit the bill.
Yeah, that's a great point.
And
well,
one more point if I can mention it. And this is one that Andrew Kosher and I have been talking about in relation to the work that we may hopefully be doing at some point. But, maybe even for nurseries, getting away from, or the entire industry really, getting away from caliper size or DBH if you're thinking about a really mature tree, but caliper stuff coming out of a nursery, and start thinking about the age of that plant material. Because if you have a slow growing species, it is going to take longer to produce in the nursery to get to a given caliper size. So that is a higher cost to the nursery producer that they may not see when they ultimately try to sell that tree. So the emphasis on caliper is really picking for fast growing trees that are profitable. And fast growing trees can have different structural or lifespan problems that we may be unintendedly selecting for.
Yeah, that's an excellent point. I'm glad you brought that up. And I think that would be an innovative way to think about it. You're buying a tree that is X number of years old, and that's what the specification is, as opposed to size. Yeah, and that would maybe relieve some of the pressure on nurseries to produce just fast growing maples, right?
Right. Yep. So, well, thank you all very much. If I am going to try to drop the URL for this article in here quick if anyone is interested.
Excellent. And I'll just point out Ryan Murphy, for those of you that are attending to get some ISA CEUs, Ryan Murphy just posted the link to that in the chat. And while Grant is looking for that, for the link to the article, I want to remind everybody that we have been recording these MinStack forums and posting them on our new U4 YouTube channel. And I've posted the link for that channel in the chat as well. If you subscribe to that channel, you'll just get the updates as we post new videos, and there'll be additional content that we're working on throughout the summer. Grant has also just posted in the link to his article. And the last link I'll post in the chat here, if you're not already on the MinStack newsletter mailing list, here's a link to that. You can get signed up to make sure that you're always informed about what's happening in Minnesota with regard to our urban forests and our MinStack forums. With that, Grant, I thank you again very much for the excellent information and great presentation, very useful. And thanks everyone for attending. Now you can go back out and enjoy the rest of the rainy part of your day. And we'll see you all next month. And Grant, thank you again. Have a great rest of your day.
Thank you all. You as well.